Hi, kids. All right, so yesterday you did some intro stuff, learning about work and energy, and then you kind of ended with a problem that should have looked something like this. Abdul had a box, and these were the forces acting on it. The box moves this way, and you were asked to figure out how much work does Abdul do, how much work does friction do, how much work does what is the network done, and then you're supposed to make some graphs. So we're going to talk about that. So first of all, okay, remember, okay, this equation from yesterday. Remember that was on your formula sheet. Okay, so hey, look, remember the College Board wants you to think change in energy equals work. They want you to think that first. And then you have force parallel times distance, where F and D have to be parallel to one another. Remember, this equation only works if F and D are parallel and if F is constant. Okay? So if we take a look. So let's take a look at these different forces. So let's just kind of go around. Is Fn going to do work? No. Okay. Is Fa going to do work? No. But there is a component of Fa that will do work. So if I draw in my components, okay, this component's not going to do work. This component will do work. Okay, this will not do work. This will not do work. Here's another way of thinking about it. Okay, remember, if our object is just this box, it can only have kinetic energy, energy of movement. Okay, so will this change the kinetic energy? No, it won't. Okay, will this change the kinetic energy? No, it won't. Will this change the kinetic energy? Yes, it will. Is it going to give it more or less kinetic energy? Oh, it's going to give it more. So that would be positive work. Okay, energy is a scalar. Okay. Which means, before, when we were talking about vectors, positives and negatives tell us direction. Well, positives and negatives now tell us, are you adding or are you taking away? It's very, very important. So make sure you understand that. So this would be positive work. Why? Because it's adding kinetic energy to the box. Okay, that one's not doing any. This would be negative work. Okay, why? Because it's taking energy away from the box. Okay, so you were supposed to have something like this, and you should have done, this parallel part, which I think it was 20 newtons. This guy, I think, was 5 newtons. Okay, and you should have been able to do 20 times 6, and wow, get 120. 5 times 6 and get 30, but hopefully you realize that would be negative 30 joules. Okay, so, but let's talk about the graphs, because you were supposed to graph these things. So we're going to make our 3 graphs, where you're supposed to graph FA parallel and distance. You were supposed to make FF and distance. And then you were supposed to make FNet and distance. You're supposed to make these graphs. Okay? So let's talk about these graphs and make sure it makes sense. All right. So as you're pulling it along, okay, remember the distance is going to be 6 meters. Okay, as you're pulling it along, what happens to FA? Well, the whole time it's 20. So all right, this is 20 newtons. So the whole time, that's what your graph would look like. Okay? Now, remember, anytime you have a graph, it's always one of 3 things. You look at the graph, you look at the slope, you look at the area. So in this case, what does the graph tell us? Well, the graph tells us FA, okay, and distance. What does the slope tell us? Well, the slope is nothing. The slope doesn't tell us anything. It's force over distance. That's nothing. What does the area tell us? Oh, well, the area would be this, and the area of this would be plus 120 Newton meters or joules. Okay, what does that tell you? Oh, that the work done by Abdul during that 6 meters is going to be 120 joules. Okay. For the friction piece, well, this is going to be -5, and this would also still be 6 meters. Well, the area of that piece would be -30 joules. So what is the friction doing? So friction is, well, this would be 0, just so you know underneath. Friction is taking away 30 joules of energy. So guess what? If Abdul is adding 120 and friction is taking away 30 joules, guess what you're going to be left with? Right, you're going to be left with 90 joules, which is also what you would get if you did this graph. This is going to be 15 newtons. If this is 6 meters again, well, guess what? 15 times 6 is going to be plus 90 joules, which means, hey, my net effect is going to be I gained 90 joules. Now, here's where you have to be super duper careful. Words are important. If it says, how much work does Abdul do? The answer is plus 120. If it says, how much work does friction do? The answer would be -30 joules. If you ask, what is the energy that the box gained? The answer is 90 joules. Does that make sense? So you have to be really careful looking at the words. All right. Hopefully you guys are good with that. Bye, kids.